In this section, we're going to create the player's script. We're going to start off creating a new script for the main player node. We're then going to ensure the player's sprite is set on the game start and also follows the mouse as expected. We're then going to add all the expected functions needed to make the player animate and attack enemies. Now let's go ahead and jump right in. Alright, let's go ahead and get started with this script. So we're going to go ahead, select the main node of the player. We are going to add a new script here. We have to make sure we're saving it in the correct location. Let's go ahead, make sure you're in the scripts folder. Open, hit create. Alright, so now we're going to start off with a couple different variables. First variable is going to be an @export. This is going to be a variable for speed. And we're going to set the default value to 800.0. Then we're going to create another @export variable. We're going to call this stopping_distance. Now we need this value because we have to have kind of like a minimum amount of distance in between the player and the mouse, or we're going to get like a glitching motion. All right, we'll set this to 0.0 for now. Then we're going to go ahead, create another @export variable. And this is just simply going to be our health, which I'm going to set the default value to 3. Then we're going to have another variable. This is going to be called destroyed. This is just going to keep track of whether our ship is destroyed or not. On start though, we always want it to equal false. We're also going to have a variable representing each type of laser we can use. So we're going to have a laser_1. And we're going to equal this to something called a preload. Now a preload is kind of like a preloaded scene. And we know, of course, we have laser 1, 2, and 3. So then if you type in the name, you should see the laser_1. Make sure it has that .tsc in there, just like that. So now we just need one for each. So I'm going to copy this whole thing. I'm going to paste it below, just like that, 2 more times. Let's do laser 2. Go ahead, change this to laser 2. Get rid of that extra part it added. Let's do laser 3. Go ahead, change it here. Perfect. Let's get rid of that. All right, a couple more variables. We're going to create another variable. We're going to call this can_shoot. And by start, it's going to equal true. We're also going to have one more variable. We're going to call this power_up_boost. And we're going to set the default of this equaling it to 0. Because once we run into our power up, we can go ahead and change this number. But on default, we don't want to have power up, so we'll leave it at 0. Save what you got so far. All right, let's continue on to our first function. So the first function we're going to create is going to be our ready function, which we know is everything that's going to happen on start of the game. So what we're going to do, we're going to do function_ready. All right, now in here, all we're going to set is 2 different animations. We need to set one for the boom and also for the power, just forcing the idle animation. So let's take those. Animation boom. Do a .play, and go ahead, play the idle. Same thing for the other one. Let's go ahead. For the power up, drag and drop, .play, simply play the idle. And honestly, we can do the same thing for the other one, which is the hurt one. It'll automatically not play, but just to be sure, let's do each one. And there we go. Simple, just like that. All right, that's going to be everything for our ready function. Let's move on to the next one. This is going to be our process function, so everything that we want to happen continuously throughout when the game is played. So go ahead, _process. Now the first thing we need to do is make sure the game is on, and we also have some health / we're not destroyed. So let's go ahead, say if global.gameOn equals true and global dot we'll say game over equals false. If both those are the case, then we can go ahead and run a function we're going to create called turn underscore on underscore ship underscore body. Now we need to have a separate function for this because of course we have 3 different ships we can choose from. So we're going to have a specific function that turns each one on depending on which player we picked. So by default, we should have each one of these turned off. Let's go ahead and continue though on this function. Next thing we're going to do is we're going to make our actual player visible. So we'll do visible and then simply equal that to true. Now by default, we shouldn't have this as visible. So you can either turn it off from here, or if you wanted to, you could set this visible to false in the ready. I'm just going to go ahead and make the player false just like this for now instead. All right, now we of course need the actual ability for the player to move around. So let's do that with a simple if. Say if capital I input dot is action pressed. And then we're going to look for specifically the left click. Now if left click does not exist for you, that means that we never set it in the original settings for inputs. We can simply do that by simply going ahead to project settings. Once project settings opens up, then we can go ahead and go to the input map and create a new input for this. And again, we're going to do left underscore click. Go ahead, hit add. Then you just need to tell it which input initiates that. So we will go ahead, plus, and we will look for the mouse button, left mouse button. Hit OK, and there we are. And again, this is how you could do it for any other key as well. But for this game, all we really need is that left mouse button click. Let's close that there. Let's go ahead, try to find that again. Double quotes, left click, and there we go. All right, so if our left click is hit, that means we want the player to, of course, follow the mouse and start the shooting. So we're going to go ahead and create a new variable in here, call it mouse underscore position, and simply go ahead and just equal that to our get underscore global mouse position. Now that will get the exact X and Y position of the mouse wherever it is on the screen. So once we have that though, then we can go ahead, we'll create another variable and call this distance underscore to underscore mouse. And we're going to go ahead and simply equal that to global position, which is our X and Y position of the player, dot distance to, and then we're going to go ahead and do mouse position. Now why do we need this? Well, this was specifically for, of course, giving us a little buffer range, because like I said, if we have the player move exactly where the mouse is, it's never going to exactly be there, causing it to flicker. This will solve that problem for us. Let's go ahead though, continue on with this function. We're going to say if, and we're going to say if our distance to mouse is greater than, and we'll say stopping distance. Then we'll go ahead, create a new variable in there, call it direction, simply equal it to parentheses set mouse position minus global position, and then we'll do a dot normalize. Now dot normalize just helps us kind of like round it up to a number we can actually use. So now that we have our new direction, then we can go ahead and simply set our velocity. Now our velocity will go ahead and equal the direction times delta. Or actually, better yet, we'll just times it by speed. If we wanted to times by delta, that would help it with the frame rate, but for this type of game, we're not really going to need that. So you can keep it just as direction times the speed that we have set. Now let's say though that is not the case. If our distance to mouse is not greater than our stopping distance, then what we want to do is simply set our velocity dot, or not dot, we'll do a velocity equals a vector2 dot 0, meaning if we are too close to the mouse, we don't want the ship to move at all. So we're forcing it to stop with a vector 2 of 0. Now beyond this point, we need to initiate the actual movement. Let me add some enters here so we can see it a little better. So right over here on this line, we're going to simply initiate our move and slide, because now that we have our calculated velocity for our character body, we need to initiate that movement onto the game. Now, we're also going to add one more thing here. That's going to be the shooting, which we will simply say if can shoot equals true. Then we're going to run a function that we're going to create called shoot underscore laser. All right. Now, outside of this is going to be on the same line as our original if statement. We need something for the health, so we're going to say if our health, let's say, is less than or equal to 0, and our destroyed variable equals false, then we're simply going to go ahead. We're going to set our global dot game over equal that to true. We're also going to go ahead, freeze our position by equaling speed to 0. And then we're also going to go ahead, turn off the ship. So take that ship node, or ships node, do a dot visible, and simply equal that to false. And then we're going to go ahead, play the boom animation. So take the boom, drag and drop it, do a dot play, and simply make boom active. All right. Then we're going to go ahead. We need to make the actual next one active, so we're going to have to go ahead. Let's do a destroyed and equal this to true. Now again, this destroyed variable is just because we don't want this to run over and over again. We only want this to run one time. So by having this here, it means it will only go once and not be able to continue. But that's going to be it. Remember, you can always check the source code. Let's save this function. All right, let's continue on to our next function. So we're going to go ahead. We're going to create our turn on ship body function. That's the one erroring out right here. So we can take that name. Let's go ahead. Let's get out of this one, go all the way from the beginning. Do a function, paste that name. All right. So in this function, what we want to do is, of course, make whichever ship active based on the one we've selected in the choose section page. So let's go ahead and say if global dot chosen ship double equals 1. Then we're simply going to go ahead and we're going to open up ships, drag and drop ship 1, and do a dot visible and equal that to true. Now we need to do the other ones, so let's go ahead, take that whole statement. I'm going to go ahead, paste this in twice below. Now let's do 2 for this one. And then of course we're just going to make the ship 2 true. Make sure it's 2, and then this one below it, do 3. And then of course the path is also going to be 3. And make sure these paths match up exactly with these ones here, or you're going to have an issue. That's going to be it for that function. You should no longer have the error, and you should be set there. Let's go ahead and move on. Now we're going to have the actual shoot laser function. So let's go ahead. Function shoot underscore laser parentheses set colon. All right. Now inside of it, what we have to tell it first is to initiate a new variable called new underscore laser. We also have to specify which laser based on the selected ship. So we're going to go ahead, do the same thing, if global dot chosen ship equals 1. Then we're going to go ahead, we're going to set our new laser equal to laser 1 dot instantiate. That'll bring it into the world. Then we need to go ahead and do an add sibling. So we can do add sibling here. The reason we're doing add sibling is because we don't want this specific laser to be attached to the player. We want it to move kind of in its own world. If we did an add child, it would be inside the player and move with the player. But if we do add sibling, it'll be next to the player, which is great because we don't want to control that location. So let's go ahead, add new laser inside of there. Then we need to specify the position. And you know what? We could do that afterwards because they're all going to start in the same position. But what we could do is, of course, start the timer. So let's take that timer to shoot, drag and drop it into there. We're going to do .wait time. And that wait time is correlating, if you select it, you'll see it, to this here. And for this ship, it's going to shoot a little faster. So we're going to go ahead, give it a default of 0.5. But because we possibly might have our power up, we're going to reduce that by power up boost. So if we have the power up, it'll of course make the bullet fire even faster. All right, let's do the second ship. Let's go ahead, copy this whole thing. Let's go ahead, paste it right below. This will be for the second one. Now this is going to be pretty similar. We are though going to go ahead, change the type of laser. This is laser type 2. Go ahead, add that in there, but we are going to change the default because this one's going to take a little longer. We're going to go ahead and make this 0.8, but everything else can stay the same. Because again, this is still going to be an add sibling, and of course we'll minus the power up boost. Let's do the final laser. Let's copy that whole thing, paste it in. Let's go ahead, make this equal 3. Then of course spawn in the laser type 3. But if you remember, this one is not going to work exactly the same. We want this one to follow with the player. So instead of add sibling, like I said earlier, we're going to do add child this time because we want it to follow the ship. Now this is going to be the longest laser wait time, so we'll do 1.5 for the default, and then of course minus any power up boost we need. All right, now we can go ahead and specify the starting location. So go back a line. We're going to go ahead, do new laser dot global position equals, and now we just need to grab the point, which is the firing point, dot global position. Then we're going to go ahead, set can shoot, and simply equal that to false. We're also going to go ahead, we're going to play the sound it makes when it shoots a laser. So let's locate the sound. This one right here, drag and drop. And then we're going to do a dot play. We're also going to go ahead. We're going to get our timer to shoot and start that as well, because we want to go ahead and time exactly when we can shoot again. Go ahead, do play. Or not play, start for the timer. Play is only for the animations and of course the sounds. And that reminds me, we forgot to add one more sound in. Back in the process function for the game over, we never added the game over sound. So go ahead, right above the boom, take that game over, drag and drop it in. Simply do the dot play, just like we did with the laser. Perfect. Scroll back down, save what you got, and we're looking good there. Let's wrap this script up with a couple more functions. We're going to go ahead now and we're going to create our area entered function. This is when we actually get hit by something. So let's go ahead and remove these extra spaces here. We can connect that area 2D signal. So go ahead, select area 2D, go to node, go to signals, and then simply select the area entered. Make sure it's connecting to the script. And here we go. So this function specifically is going to be for when another area 2D enters this area 2D. So of course we need to find out which one it is, which we can simply do with an if, and we're going to say area dot is underscore in underscore group. Now we're looking for a specific group name tag called enemy. This is what we're going to attach to each enemy type ship. Now when this happens though, we're going to go ahead. First thing we're going to do is play the hurt animation. So let's go ahead, drag and drop that in. Do a dot play, hurt. We're then going to, of course, minus some health. So take our health, do a minus equals 1. Next thing we're going to do is we're going to say if our health, and we're going to say is greater than or equal to 1. If that's the case, we're going to go ahead, play our specific sound for getting hit. Now the reason we're doing this is so they don't overlap with the game over sound. This is just a nice little safety net. Then, last thing we're going to do in this if statement, we're going to go ahead and start our power up timer, okay? So we're going to go ahead, we're going to find the power up timer, which we don't have yet connected. If you want to connect it, you can, just simply select it, go to timeout, connect it to the script, and then we're simply going to just run this. Reason being is we don't want to have our power up active. If we get hit, it's going to cancel it out. So go ahead, add that there. Perfect. Now we can do the actual power up. So I'm going to take, again, our if statement for is in a group. I'm going to go ahead, paste it on the same line as the original one. And we're going to look for specifically lowercase power, capital U up. Now if we run into that power up, then we're going to go ahead. We're going to remove the power up from the world by doing an area.get underscore parent. And the reason we're doing a get parent is because the area 2D we're hitting is a child of the main node. So sort of like how this is, and there's the main node. If we want to get rid of everything in the main node, we have to get rid of the actual parent node. So we're going to go ahead, do get parent. We're going to do a dot q underscore free parentheses. That will go ahead and remove the power up so we can only collect it one time. We're then going to go ahead and set our power up boost, simply just something small like 0.4. We're also going to go ahead, play our power up animation. So we're going to go ahead, take our power up, drag and drop it, do a dot play, and do the power. We're also going to go ahead, start the power up timer. So take power up timer, drag and drop it, and do a dot start. Now this power up timer, we're going to go ahead and we're going to set it. Let's specifically set it to something like, I think 5 seconds. If we already didn't do it, which we already did, that's fine. If you want to adjust that, you can, but 5 seconds should be good. Make sure it has that one shot on as well. All right, and that's going to be our area 2D. Now, specifically for this timeout, what we're going to do here is just turn off the power up. To do that, we're simply going to go ahead and we're going to do power up. And we'll do power up boost, equaling it to 0, which we'll go ahead and turn it off. We're also going to go ahead though and play the power up idle animation. So take the power up, drag and drop it, do a dot play, and then do the idle. Now we just need our last function, which is our timer shoot. Select it, node, timeout, connect it. And all we're going to do in here is simply set that can shoot, equaling it to true. And there we go. We should be all set. Let's save everything we got here. Remember, you can always check the source code. Let's go back to 2D view. All right, let's go ahead and test some things out. Let's go ahead, select our main scene. Let's drag and drop our new player. So scrolling down to your yellow folder for components, locate the player.tscn, drag and drop it onto main. Go ahead and make it visible for a second. We just want to move this right on over here underneath the play button. I'm going to make it invisible again. Let's save what we got. Let's go ahead, start current scene, let that load. All right, hit play. Select which ship you want to use. I'm going to use the tank. Hit choose. Let's make sure the player can follow the mouse. Perfect. Now if you want to adjust the distance, you can. Let's mute this for a second. But it looks like everything's working pretty well. Let's make sure we can't go across the borders, which we can't. Nice. All right, let's close out of there. Let's adjust that distance so we get less glitchiness. Select the player here. I set my stopping distance to 10. We might need to increase that to something like 15. Let's save what we got again. Let's go back to main. Let's go ahead, start current scene. Let that load, hit play. Go to ace this time. And there we go. Looks like it's not as glitchy, which I like it. Overall, looks really well. Let's close out of there. Close up the output. Close up our folders. Let's save what we got. And we're looking good.